Differential Calculus 2015 question 10. Two cars A and B start from rest at O and begin to travel in the same direction. The speeds of the cars are given by velocity of A is equal to t squared and B 6t minus 0.5 t squared. And it's measured in meters per second, and t is the time measured from the instant they start moving. Easy intro, find the speed of each car after 4 seconds. So velocity of A is going to be 4 squared, which is 16. And the velocity of B is going to be 6 by 4 minus 0.5 by 4 squared, which is 24 minus half of 16, which is also 16 meters per second. In part 2, we're asked to find the distance between the cars after 4 seconds. We know what distance is. The distance from our linear motion equations is ut plus a half at squared. So we don't have acceleration, so we need to find, we'll just see where this velocity comes from, the s dt. So if we just differentiate s with respect to t, we're going to get u plus a half times 2a t, which is equal to velocity. So to get from velocity backwards, integration is going backwards. So we need to integrate these two things. So we need to integrate t squared, and it's in the first 4 seconds. So that's going to give me t cubed over 3, which is equal to 4. I'll put in the 4, it's 64, but it's 4 cubed over 3, which is equal to 64 over 3 meters. If we integrate, and this is A, if we integrate B, for the first 4 seconds, it's 6t minus 0.5 t squared. And if we integrate that, I probably should have put dt in the top one as well. We're going to get 6t squared over 2, so 3t squared, minus 0.5 t cubed over 3. And if we put 4 in, the 0 will just give me a 0 value. We're going to get 3 by 4 squared minus 0.5 by 4 cubed divided by 3. So that'll give me 3 16s, or 48, and half of 64 is 32, so 32 over 3. Just use your calculator, or 348 or 144 minus 32 over 3 is going to give me 112 over 3. So the difference between them is 64 over 3 and 112 over 3, and the difference between these two things is 36 plus 12, which is 48 over 3, which is 16 meters. Part 3, we're asked to sketch the speed of A and B on a speed time graph for the first 4 seconds and shade in the area that represents the distance between the cars. Okay, let's get our 4 points. A is t squared, so t is equal to 1, 2, 3, and 4. And so we've got a 1, a 4, a 9, and a 16. So these are my points. For B, we had 6t minus 0.5 t squared. So we can get 4 points. You could get more. You could get a half, 1, 1.5, 2 if you wanted, but I think this should be enough. So we've got 6. Putting 1 in for t, we've got 6 minus a half of 1. So 6 minus a half, 5.5. Putting 2 in, we get 12 minus half of 4. So 12 minus 2 is 10. Putting 3 in, we get 18 minus half of 9. 18 minus 4.5 is 13.5. And putting 4 in, we know we get 16. We've already done that. So these are my 4 points for B. So we're asked to sketch. I don't have a ruler on this, so you will probably have a more accurate diagram than me. 1, 2, 3, 4. So this is my time in seconds. And this is my speed in meters per second. We need to go up to 16, so let's go up in twos. 2, 4, 6, 8, 10, 12, tiny bit more. 14, 16. They look pretty evenly spaced. 2, 4, 6, 8, 10, 12, 14, 16. You will use graph paper in an exam anytime you're asked to draw a graph. So let's see, can we sketch this? A, let's do them in different colors. Let's do A in red. So 1, 1 is approximately here. It starts at 0. 2, 4, approximately here. 3, 9 is approximately here, and 4, 16 is all the way up here. So quite steep growth after a slow start. Then we are going to do B. Let's do it in blue. So we have 1, 5.5, approximately there. 2, 10, 2, 10, approximately there. 3, 13.5, and same point. So and obviously the area, the distance between them is the difference between the curves. So this is my shaded area. That represents the distance between them, which we got to be. What do we get? 16 meters. So that's that question done, part A.